Hello, everybody, and welcome to Kasten Kickstart or Kickstarting Kasten. Today is part 10, and today I've changed the topic, and I'll tell you why. Because yesterday in the evening, when I was playing around with my Kasten setup and my Kubernetes cluster, I ran into an issue which I've run into in the past, and I never learn, in the sense that it doesn't always happen, but I should know when it's going to happen and I prepare beforehand. So before I get all muddled in my speech, let's remember what we've done. We've created a single node Kubernetes cluster on a Rocky Linux VM with Kasten, with Longhorn, with KubeVirt, okay? We've added a lot to that. If I just done K3S with a deployment and maybe Kasten and that's it, I might not see this. I might eventually if I add a lot of workloads, whatnot. But with all the things that we've added, we're going to definitely see this. And it's a little error message. It might be an error message on the console, or it might be some weird behavior of pods. But the error message on the console is too many open files. It's like, what? This is a GUI-less server. I don't have File Explorer in Windows. I haven't opened any files. These are the dreaded file descriptors. And let me explain what they are. And first of all, I've seen this in the past, especially when I load KubeVirt in, because KubeVirt's got operators and it's going to add VMs. It's not a RAM or CPU problem. The first time I ran into this, I decided to add more RAM. I thought this might help. Didn't help because it's something to do with the way the kernel is configured and these file descriptors. These are Linux resources, but not resources in the sense of memory or CPU. Okay, this one in particular, file descriptors. What are they? And I actually got a really nice, eloquent description rather than me just babbling on. File descriptors are handles that programs use to access anything. Files, network connection, pipes, devices. In our case, Kubernetes, every time the kubelet, and the kubelet is a little program which does all the hard work. So if I want to create a pod or a VM, the instructions go to the kubelet and it does all the magic. So it's doing all the juggling. Every time it opens like a container log or creates a volume, or establish a connection to the API server, it uses a file descriptor. The problem is that Linux defaults, and I think different distributions might be different, might be the same, I don't know. Maybe not, maybe it's the same. Defaults to only 1,024 file descriptors per process, right? But a busy kubelet managing 50 pods can easily need 2,000 or 5,000 file descriptors. Boom. Not to mention KubeVirt and everything else we've added on there. So in our case, for instance, we have Longhorn, which adds more with its volume engines and iSCSI connections. KubeVirt needs file descriptors for VM disk and network devices. So there's just a whole bunch of things that are going to happen there. And as it says here, you will get the too many open files error. Okay, great, Jeff. You've gotten that. What do? Just, give it 20 more gigabytes of RAM? No, it won't help because these are hard-coded. So I did a few things because I kind of understood this a bit, but you don't do this every day. You forget about it. I'm not a kernel developer. So I Googled a bit, I did a bit of AI searching, and combining everything, I came up with, I think the best description was actually on a, not from AI, but from a website, which I'm going to find right here. 1 second. And I will pull this up and put it on the screen from my beloved, the Kickstart website. I don't know if you know this website, but I really love it. I've gotten so many great pieces of explanations there that I always recommend it. So it beat AI in this case. AI came out with a good explanation, but it also, tells you like the beginning of time, what happens. Like, no, I don't need that. So what am I talking about? I'm talking about this with my face in there as well. This site here, Kickstart how-to, Debian Linux, because it's about Debian, but it's the same thing. Relatively new article, but this is something that's been around for a long time. Increase your maximum number of open files, file descriptors. So that was my problem. So it discusses, it's a tutorial, right? So it's great. So it actually is something hands-on you can do. You don't have to wait until your Kubernetes cluster gets annoyed. So first of all, it gives us a nice description, similar to what I just said. So in Linux systems, a file descriptor is a handle used by processes, such as, in this case, Nginx, MySQL, whatever, to interact with other files, network sockets, pipes, or other in and out resources. Fine. Why are the limits important? Okay, soft and hard limits. Okay, that's something too. Soft limits are the currently practical limits. They cannot exceed hard limits. A regular user can increase their soft limits up to the hard limit. Okay, root or privilege processes can modify both soft and hard limits. So something to know, maybe a little bit too deep for our needs. There's system-wide versus service-specific FD limits. So you can actually set it on a service if you want to, right? So system-wide, you change it across the board for all relevant users and services. That's what I did, because I'm not going to fool around trying to piecemeal this. Plus, all my things in K3S are going to need this anyways. Or you can do user or service specific. So you can actually say, okay, let's say there's an Nginx user in this case, or a MySQL database user. It needs a lot. You can change that for them, okay? Here are the commands. This is where you can actually see it. So why don't we actually try this in our cluster for fun? Always nice to try it. Go to our, there we go. So there's mine, okay? That's after I changed it. Obviously, it was a lot less than it was before. So the output, look, he's got 7, or whoever's got 75,000. I have more. That's the commands on how to see the different levels, so the hard limits and the soft limits. And then if you want to see per user, and goes into even deeper descriptions, okay? What I did, and what is important in my case, and I don't think you could wing this by user or whatnot, is just use system-wide, especially in a demo. I don't want to spend time fixing this. You can do the command like this, sysctl. The problem with that is if you reboot, it goes right back to default. Okay, so I did not do that. Instead, you can actually change the system sysctl.conf. But better practice is to create your own one that specifically deals with this, right? Then you put these in, and so I will show that as well. If I go to etc, and I'll go there, and then it's going to be sysctl t. And then I actually created, so there's the default one, and this creates 99. I created this Kubernetes one. And I actually didn't just change the file descriptors, right? Limits. So there's my 209, is that 209,000? No, it's like 2 million or something. No, my math, I can't see my glasses. I have to make the screen bigger, but it's a lot. But I also added some other settings in here which were recommended, just so I haven't added these issues with the other things like iNotify. I didn't run into that problem. Or with memory map. Memory map, I've seen in the past, it comes out so they can't allocate memory, and you've got like 64 gigs, or what are you talking about? So I put that in there as well. But the one that I run into very often when it's a single node cluster and I put too much in there is the descriptor. So that's the one I changed. Okay. So more information here about how you can see it, talking about user or service level FD limits. So this is a great article. I mean, this is one of these things which you won't, I mean, I don't see AI replacing this. Someone's actually written down this, cut it out, removed all the baloney, lean, mean, exactly what I need. So I will put this in the instructions that I give everyone. In fact, I'm going to put in the instructions the setup instructions. I'm going to put right away to change those default settings in Rocky Linux before even installing K3S. So way before the problem even arises. Makes things a lot easier. Okay, that's enough for today. System's running, there's no problems. And in fact, it didn't really even collapse that badly. What I started to see was I updated my Kasten. It was either a newer version or something I wanted to change slightly. And some of the pods weren't coming back. So they were like stuck in initiating stage, right? And then I was kind of wandering around, and then on the console, I saw that too many open files. Okay, right away. I changed that, and it recovered by itself. Beautiful thing about Kubernetes, it self-heals. So a lot of times, it's not after you give it a kick or something, it actually fixed itself. All right, we'll see you in part 11 tomorrow.